here, Senior Plus software engineer with 10 plus years of experience. I'm the lead maintainer of Latterly.io, an educational platform that will help you land your first or next programming role. And I myself am preparing for an interview doing some shadowboxing today. We're going to cover this interview prep tip for shadowboxing system design. And I'll be using Claude AI. And if we have time, we will also check out Hello Interview AI and we'll be able to compare them. So let me go ahead and share my screen. So here's Claude, and the way this works is I'm going to have it ask me a random question, and then I'm going to go over to Excalidraw and make a picture, and then I can actually screenshot the picture, send it to Claude, and have Claude grade the picture. I can also give it a text write-up of the picture if that helps as well. Hello Interview will be, just in case we don't get to actually use it, I at least want to give them a shout out. They have a YouTube channel, absolutely fantastic, highly recommend. And then the website is hellointerview.com. They do FANG interviews with like real engineers, but they also have an AI tool that I haven't used before. AI. Let's see if I can find it. AI mock interviews. Cool. So these are going to be AI mock interviews, and maybe we'll do one of those later. Okay, so, and I'm using the Claude 3.5 Sonnet. So role, you are a senior plus engineer at a well-known tech company. It doesn't need to be FANG, but I don't want this to be representative of a no-name company. So you're a senior engineer at a well-known tech company that operates at web scale. We'll say that. So it's going to be you are providing, I guess this is situation. You are giving a system design interview. Task. Ask a system design question. For now, do not give any hints. Design a distributed, scalable URL shortening service. Awesome. Well-known question, also one that I haven't practiced. So this is going to be, haven't practiced in a while. So this is going to be great. So generate short URLs from long URLs. Redirect users from the short URL to the long URL. And so I'm going to ask some questions here. I presume we are operating at global scale. I would expect around $1 billion for like a Facebook, but honestly, I don't think people are going to be using link shorteners as often as they use Facebook. So I'm going to expect around 10 million MAUs and around 1 million DAUs. Does this sound fine? How many reads and writes per user per day? Oh, reads and writes are going to be equivalent at peak. Huh. I wonder if that's, oh no, okay, it's 10x. I was going to say I would expect it to be write heavy, a URL shortener. Cool, so we're write heavy, or sorry, we're read heavy. That's expected. So we have this data on reads and writes. Redirect users, allow users to customize their short URLs if available. And so we'll need some sort of authentication service. Now I want to know, is there an expiry? Is there a limit to how many of these a user can do? And I'll propose that. Basic analytics on URL usage. So I'll propose that. And then I will also propose an expiry. No, no, I don't need to propose an expiry. If you are a registered user, you can have permanent links. What if you're not a registered user? Can you create? Did my mouse just die? I think my mouse might have just died. So if you're not a registered user, can you create? I would propose that registered user links never expire, although we may notify the user if their link continually 404s or provides some other error. Is that I would propose a cap on free user account link registrations. Would a cap of 20 or 100 per user account be acceptable? I would propose that only registered users can create short links. Is that acceptable? Guest users can only read. So here I'm simplifying my own. What is this? Never mind, it says at bottom. Yeah, it's Claude. We're using Claude. So here I'm simplifying the problem relative to what I'd actually do in the real world. In the real world, I would let free users make some short links, but I'm simplifying the problem for myself by saying that guests just can't write. Let's review each of them. Registered user links never expire. Good policy. Okay, so they confirm it. Cap on free. Seems like the interviewer is accepting it. Only registered users can create short links. It seems like Claude is accepting all this stuff. Since only registered users can create links, our write operations might decrease slightly. Okay. Cool. It doesn't really impact our architecture though. Yeah, we're going to need auth for sure. We need to track these. Great. So I think we're in a place where we can start to draw now. And I really lost my mouse. What a bummer. Let me charge it. Sys design pro tip, make sure your wireless mouse is charged. Okay. I'm also going to presume a web client. Is this okay? It's hollow. It's hollow in there. So functional. Whoa, it's really small text. Functional. Requirements. Auth system. Guests can read links. Users can create links. Users get basic analytics like clicks on their link per day. Okay. Cool. We'll basically leave it at that. And then non-functional. Handle 2K per what? Was that second? Yeah, per second. Handle up to 2K reads per second. Handle up to 500. I think this is higher than the requirement. Okay. 138 writes. So we'll say up to 200. Yeah, it's a 10 factor. That makes sense. Handle up to 200 writes per second. Global coverage. we're going to want to have, so now we need to think about the CAP theorem, right? So we're going to want to have low latency, global coverage with reasonable latency. And we're going to want to think about consistency and availability. So consistency, only one user can register one short link, and every short link can only have one destination. Okay, and then availability, reads should be highly available and they can be less consistent. So if someone updates a link, well, we're not letting them update a link, are we? I guess I could say you can create and delete, but you can never update. But then those are going to be equivalent if you create and delete. Create, delete, and update. So users can create, delete, and update links. Reads should be highly available. It's okay if the destination value is slightly stale on the order of seconds. So if a user updates a link, then short link consumers may get an out-of-date link on the order of seconds, and we'll accept that. So that's going to be our high availability consistency trade-off. You can see we're picking something that's different for short link registration versus reading. We're actually doing both in different segments of the system. Okay, so we got those written up. Let's draw these. I'm going to have some client. We could do mobile and web clients differently. I'll skip the differences here, but I'll just call them out. So this will be like mobile client. And here will be web client. And then I'll do a note. I won't say much about the differences, but one would be push notifications for link analytics. So you could send someone a push notification and be like, congratulations, you got 1,000 views today, you're trending or whatever. So that would be something you could do with a mobile client that you typically wouldn't do with a web client. Okay, so then we're going to come over here. We're going to do a caching layer. So this is going to be CDK. We want to cache reads. CDK is kind of looking like a physical cache. Let's see, do we want to use Elasticache instead? Yeah. And we can do Elasticache per region. We'll skip this CDK. So these people are going to come to an auth layer. Let's see. If you're a guest, do you bypass the auth layer or do you technically go through the auth layer and it just says that you're not logged in? I think we'll do that. So everyone is going to go through a load balancing layer, and then they're going to go to an auth layer, and then they can go to their actual service. And how many services are there? There's going to be a registration service, and you can read in the same service. I think it's fine if you read in the same service. Then that service will be connected to its own Elasticache database. There's a trade-off there. I need to think about that more. Do I want there to be two services and they each get their own database, or do I want there to be one service that connects to two databases? Let's make it work and then make it work better, right? So by making it work, we're going to start with one service, and later we can decide to split it if we want. So for now, we're going to say that there's one service pointing to two databases, and if that proves unwieldy, we can split the service layer. Okay, so this is application load balancer. And why do we like application? So I can redirect based on the content of the request. An example of this might be If I notice that a bunch of people are using one short link from a geographically restricted area, then I might want to preferentially balance them towards the services in that area. So this stack that I'm describing will be a per region stack. This will be a per region stack. Could I use like a dynamo, which would be global? Yeah, maybe I don't necessarily want a per region stack. So we can get away from Elasticache if we have like Dynamo with DAX. Elasticache, I'm going to need a Redis per region. With Dynamo with DAX, I don't need that. So I think that's simpler. And I think it works fine for, actually, it's better for global consistency. Because if you have a Redis per region, then Jim could have abc.com in Europe and Sarah could have abc.com in Congo. And it's like there's not global consistency. So I think it's actually better to have Dynamo with DAX, and that'll be outside of the region. That'll be outside of the region. And so my load balancer is still inside of the region. This is my service layer. It's going to be inside of the region. Okay, so let me put a boundary around and then mobile clients will be, mobile clients will be directed per region. And so this will be like our regional stack over here. So this is going to be the regional stack. And then out here, I've decided I'm not going to use Elasticache. I'm going to use Dynamo with DAX. For global consistency and low latency. Global consistency on links. Okay. How much time do I have? Okay. We might only get to the one system design question. Or not. I mean, this is pretty close. So here, what about my authentication? That's something that I'm missing. So I can do Dynamo with DAX for my links, but I will not do my user registrations over there. I want my user registration to be SQL. And that way I can do things like salt. Well, you can salt your password even with no SQL. Let's see. Why do I want Postgres? It's open source. It's reliable. It's secure. It's high performance. And it does what we need. It does what we need. So an auth system is inherently relational. I have users and roles. And users have their passwords and things like this. So it's inherently relational, so that's why I'll go for SQL. You could do this with a NoSQL database. I actually don't think it's that interesting of a difference, but there's a quick justification for using Postgres. And if I'm using Postgres, that means I'm using RDS, which means it's part of my regional stack. So here is PGRDS. And this is mainly for auth. PGRDS mainly for auth. Okay. So my load balancer is going to go here to my service layer, and then that can echo back. We can do the back arrows as well so that our clients get a response eventually. And so this will be service layer. And I'll have let's see. Do I want to scale these independently, which might make me break them up? So I could split my reads from my writes. That's a good reason to break up your services. You can also scale independently, and the scale will be different, right? I'm going to have crazy throughput or like a 10x difference. A 10x difference means that my pods will scale differently if I do this in Kubernetes world. What if I do this in Lambda world? They're going to scale fine in Lambda world. This is not a problem for Lambda. And if I have all of my code in a Lambda, then it's going to scale regardless of read or write. So Lambda, Kubernetes, those are the main two options. What would be a different option? You can do it EC2 or ECS. I don't want EC2 or ECS because there's just too much manual configuration. So I'd rather use either the question to me. So I want to be able to scale these with minimal configuration. So I either want to go the Kubernetes route or the Lambda route. So what would be a decisive thing for me is if there's a blocker to a serverless pattern here, which I'm not seeing. This seems compatible with serverless. Or if there is a need to scale pods differently, then you would want the code split out into different services. And here, maybe sessions are interesting. I'm not seeing a reason that I need a long-running process. Reads and writes. I mean, there's the cold start problem at this scale. It's not a problem. Handle up to 2K reads. Handle up to 200 writes. I'm not seeing it. I think it works fine with a Lambda. So I'm going to, well, then cost would be the other reason. So if there's no reason so far to distinguish between Kubernetes and Lambda, Lambdas are simpler and they're also cheaper. So I think we have a couple reasons to push for Lambda. Easier setup or easier management and cheaper and no blockers in this system requirements. Cool. So if we have Lambda, we can actually do what's called like a mono Lambda and just put all our code. The ability to create an account, log in, read and write, it can all just go in the one Lambda. Okay, so I think this seems good. And then let's do a bit about some of the nice to haves. It's worth saying that like we want authentication stuff. Encrypted in transit and at rest. So authentication, auth details, encrypted in transit and at rest, e.g. password. We can use a signed JWT. You could also consider database tokens, which are going to work fine since we have RDS. So I'll use both. I can use a signed JW token with DB session tokens. You can do both. You do CSRF if you care. Like, do we really care about people creating links in another person's account? I guess let's also do CSRF for logged in users. I guess we'll prevent it. Why not? It's cheap enough to implement CSRF. Also, if that gets hacked, I don't think it's the end of the world. There's a limit on how many they can create. So some user might get hacked and then they would be like, have a bunch of URLs that they didn't make. It's not like this is like a bank scale issue or something like that, where people are getting robbed. But still, let's prevent it. Why not? It's easy to prevent. So those are going to be some interesting security details. And here, I want to talk about observability. So observability, we need a log store. I'll use a third party here. I'll go for a Datadog. That's going to be more for monitoring than for the log store. So let me bring that down here. So we'll do monitoring with Datadog. We'll have on-call with PagerDuty. Okay, for the log store, Kibana is coming to mind, although practically I don't use that one much. Splunk, we'll go with a Splunk. It doesn't really matter whether it's Splunk or not. It matters that we have a log store. And the other interesting thing is that back end and front end can both report to here. That's the other interesting thing. Cool. And then you could also do an analytics layer. You do reporting service. If you have some business analysts who care about like links per day and stuff, so you could have a reporting service plus analytics layer, or like a data lake over here. And that's kind of a less interesting thing, but if you wanted one, that's how you do it. Aren't you missing CrowdStrike? Yeah, sorry, I forgot CrowdStrike, where CrowdStrike goes in this design. I think we can include it in most of our desktop clients. I haven't drawn desktop clients, but if I had them, I assume they'd use Windows. The ALB, we can make sure that's using Microsoft Server. We can get some CrowdStrike in there. And then, yeah, I was talking a lot about Lambda, but these services do exist in the Azure cloud. So we can just convert all of that over to just Windows servers and have 3 layers of CrowdStrike. That was a joke, in case anyone thought I was serious. That was a joke. So this is looking pretty good. Let's review the functional requirements just to check. So the auth system, the user comes into here and then they go to RDS. Great, I have a session. And then maybe I could say something about the ALB making sessions sticky. I don't care if the session is sticky. I don't need to deal with that. I have Lambdas, they can be stateless. So we're using a JWT. Database session token is going to be an interesting detail because my RDS is per region. So we do want regionally sticky requests. So if someone is like logged in and then they cross region boundaries and their thing is like not connecting anymore, they might have to log in again. I can bite the bullet on that one. It doesn't seem like the end of the world. Or we could have like a pass through where it's like, then this would need to be like a routing service, which is okay because it's an application load balancer. So I can do more stuff with it. So if my request comes in and I know that it's a session that originated in another region, I might need to kick them back to their origin region and they might get like slow responses. That's an option, or we could just make them log in again in the new region, which I think is simpler. So I'm going to bite the bullet on that. And then in the future, we could always add the rerouting if like data shows that user experience prefers that. But I'm going to guess that users don't want a ton of latency. So I'm going to guess that this is actually better. Is there any Redis in here? No, we've gotten away without Redis. We're using Dynamo with DAX instead of Elasticache. Okay. And then we're handling the load. We have global consistency on the links. And then we have highly available reads. Let's see. If my web client wants a read, yeah, I'm basically getting it from Dynamo, which is going to be quick. Cool. So I think we've satisfied everything at this point. Now, in a typical interview, not only have I satisfied the basic requirements, I've already gotten some of the nice to haves like observability, security, and extension into a reporting service for analytics. So at this point in a typical interview, what I would begin, first of all, I'd confirm with the interviewer if it meets the basic requirements, and then I would begin proposing enhancements. But for the purpose of today, I don't want to go into that. I just want to see what Claude thinks. So here is my system design diagram. Let me know if you have any questions so that you can understand the proposed architecture. If it makes sense, go ahead and grade my answer on a scale from 1 to 10. If you have questions, do not grade yet. Reserve grading until ambiguities are minimized. So are you setting microvolt values to pixels in coding? You know what? That felt like a joke, but I think you just made me remember that I totally didn't talk about analytics, like the user analytics here. So where do the user analytics go? If they're basic analytics, like a count of clicks, do we want to do that in Dynamo? You could. If it's literally a counter column, that would work in Dynamo. But you don't want to use Dynamo as a transactional database. That would be RDS. So the question is going to be, what analytics do they get? If it's clicks per day, I think I can get away with Dynamo. I think I can get away with Dynamo on clicks per day. So there would be two columns. There would be the counts, and then there would be the count start time. Yeah, and that would basically be reset daily. If you want more advanced things, we're going to have to push into RDS. Okay. It's a well thought out architecture. I'll go through key components, data storage, Dynamo with DAX, notable decisions, use of serverless architecture. Look, Claude is picking it up. Let's go, Claude. Global coverage with reasonable latency using Dynamo, separation of linked data and user authentication. Yep, you got it. Emphasis on security with, consideration for analytics and push notifications. Yep. How do you plan to implement the URL shortening algorithm? Is it handled in the service layer? Yes, it is. Yes. And I expect I can use a UUID. Let's see. An algorithm, a function. So I think the magic word you're supposed to use here is hashing function. And so hashing functions are interesting because they're non-reversible. I don't actually care if it's reversible though, do I? I don't actually care if it's a pure hashing function because I don't actually care if it's reversible. So I can just use a function which converts the, in fact, I need it to be reversible because I need to know, oh no, I don't. Let's see. The user is going to request and then I'm going to send them the right one. So you could just have a map in your database. That's exactly what we're doing. There's a map in the database. So it's reversible from the database. It's not reversible in the function itself. That's fine. I actually don't care if it's reversible or not. Which converts the like destination URL. Look, it's just a function. It's not actually that interesting. So if I say UUID, then the question is going to be, aren't you exhausting too many characters? You could use other symbols, and that's perfectly true. That's perfectly true. Let's just go with the UUID for now. I want to avoid like weird symbols and emojis. I want to avoid that in my link, even though it would allow you to access a greater UTF space. I just don't want to do it because it looks weird. And if users are irritated, if it actually becomes a binding constraint, we can introduce some exotic characters. But I would default with just a UUID. I don't think that constrains the system. Yes, and I expect that I can use a function which converts the destination URL into a UUID based short URL. Does this seem fine? I acknowledge that we could access a greater count of short URLs if we support exotic characters, but I don't think this is a binding constraint on the system. And I think limiting to UUIDs makes for prettier URLs. So do you need to know how computers actually work or just the programs? In a typical system design interview for distributed system design, you will not be asked about like operating system details. It's literally never come up for me. It's literally never come up. I've literally never had someone ask whether I meant to use like a Microsoft server or a Linux server or Ubuntu and like what the differences were. I've literally never had that question come up. And it's also easy to diffuse, right? Because if it comes up, you say, yeah, I usually go for Amazon Linux or Ubuntu. Pretty like, I do not encourage you to say, I really want these to be Microsoft server. I don't encourage you to say that in a system design interview. You can say Amazon Linux because it's the Amazon standard. It's like, it's the gold Omnis they recommend, or Ubuntu because it's like open and trusted and stuff. It's a reasonable choice. Cons, yeah, they're long, which isn't as short as some other services. Oh, bummer. Okay. They're still not as clean as some alternatives. Oh, dang, I just got wrecked. Okay. Yeah, no, sequential IDs, base62 encoding. I didn't even think about that. Why base62 and not base64? I don't know. But sequential IDs would definitely be prettier, wouldn't they? The thing about sequential IDs, though, is, again, they're limiting your space. So I could go 1 through 9, but I could also go A through Z and access a greater... Okay, fine. I guess this is like continuing with my own logic. If my logic is, we'll address it when it's a binding constraint, the question is like, are sequential IDs even a binding constraint? And it would be on me to prove that at some point they are. So I think the truth is at some point they are. 32 characters long means like 32 zeros, which is a lot of UUIDs. Yeah, so we can scale pretty far off of sequential IDs. And you can introduce characters. I mean, you can call it a hashing function, but I just don't care about the reversibility piece. That's why I'm ignoring the word hashing. Probably it's not a good look in an interview, and I should just say hashing function, and then call out that actually it's not a big deal if it's reversible, but pretty much I'm talking about a hashing function. For the consistency requirement, how do you handle potential conflicts or race conditions? Okay, so the race condition here, this would be an unlikely case, but the race condition here would be that Jim tries to reserve foo.com and Sarah tries to reserve foo.com at the same time. One thing you could do is you could queue them so that there never will be a race. Locks are another solution. You're not going to put a lock on DAX. You can put a queue up to DAX. So then you would have a global queue of writes, which is on the one hand fine, but on the other hand, it could be a fragility concern. You're going to have a global queue of writes. And so I want to make sure I have some sort of replication or failover for that. Yeah, I think I'll go for a global queue of writes, and then I'll have Kafka text-based failover. We'll basically have failover support. I'll use a global queue of writes, so there will never be a race. I recognize this can introduce a single point of failure concern. So replication and failover will be important. I'll use a Kafka queue equipped with text-based failover backups. Now the question will be, do I really want to back up the whole global queue, or might I have some smaller queues, but then you lose the consistency? Then you lose so you really need a global queue. You just really need a global queue. I'll use a Kafka queue equipped with text-based failover backups and text-based failover, so we can do point in time restore. In the worst case, both link creators will fail to create their links, but we preserve consistency by never double allocating links. Okay, and then I'm going to ask, we're pretty much at time, so I'm going to ask Claude to go ahead and grade me at this point. Overall, this is a strong solution. Gang. That's a way to make you feel good. You need both, bro. I don't think you do. In fact, I think if you have both, it complicates and it actually weakens the solution. I think you really, really want one that's failover resilient. Because think about the consistency problem. If I have micro queues in my regions, then Jim and Sarah can still try to double book. They're just going to be in different regions. So it makes the problem rarer, but not fully solved. Okay, given time constraint on the interview, go ahead and grade on a scale of 1 to 10. Give your feedback about overall strengths and weaknesses. Now, this is Claude, and Claude is tuned to tell us what we want to hear, right? So it could definitely just be being nice. Well, comprehensive, it's complex. That's fine. I'll bite the bullet. Single point of failure. Yep, I acknowledge that. This one I feel is an actual weakness. While you've mentioned DAX, a more detailed caching strategy, fine. I think this is the only actual pushback is that, yeah, it would be much simpler to just do counting. Thank you. Let's say that I went for basic. Let's see. I think I'm actually out of time. Yeah, I gotta go. All right. Well, that was fun.